That's fine. So, ladies and gentlemen, and welcome to our afternoon's event. At this event, I'm going to share our commercial and industrial BESS system, also including the microgrid solution. And for this presentation, I will focus on the financial plan and the overall product list, and finally, our proposal for our customer. So let's start. So first of all, let's get a quick introduction of our company. So our company name is LVFU. So this is based on the version of our boss. So he wants to focus on the medium vote and create the future universal solution for our customers. So for us, we are basically in Chengdu. Why is in Chengdu? Because Chengdu is the center of the power support of overall China. It's on the middle side of Yangtze River. So we use the electricity created from the river and transport to overall China. So that's the reason why we set our factory there. We have good talented people, we have good teams, and we have the history to build the factories. So we have two factories. One is in Chengdu. So in Chengdu, we create the large-scale energy storage system, and another factory based in the Fujian. So Fujian, everyone knows, is near the sea. So because of the good location, they are building the residential BESS system. So that is our situation. This is our capabilities. Before the LVFU, we are already established over 10 years. And we do the government project. We do the large-scale business project. So this relates our capability. So we can produce the battery for ourselves, and we can develop the new products, even customization. Then is our service strategy, which is localized operation. So as we know in the morning, the SunCross, which is our partner, they are doing the presentation. That is our service as the regional. So we find the local installer, we find the local warehouse, we even build our own local companies based on this region, so we can provide the good service for our customers. This is our global project customization. Why you say that? Because the project is not just a small project. We are also dealing with a big project, like over hundreds of megawatts, or even gigawatts. So based on that, we have our own EPC team. So EPC team, including the project manager, technical manager, consulting, financial manager. So all those roles we can provide. So this is our service scope. So there has three markets we are most focused on. The first one is here. So we have Philippines, like Malaysia, Indonesia, and also the Thailand. And the second thing is Europe, which is where I come from. I and my colleagues, we have two people in charge of European market. And for them, we are providing our VPP project. VPP means virtual power plant, And then is some other vision. And you see the house icon here means here we have our own warehouse. And if you have seen the person here, it means there is our service. So just like in Malaysia. Okay, so quick introduction for our product line. So in the morning we just mentioned about our ESS system. So today I'm gonna introduce our industrial and commercial ECACs, which is an integrated cabinet. This cabinet including everything you need about power, not just battery. These are containers. And third thing is our PV module, which is a third part. This must be mentioned. So why we do that? Because in a big project, you must have the detailed calculation for everything, including the PV, the batteries, and how to connect. That is everything. We have to control every part for the delivery. Okay, so let's move on. For the Malaysia market, the most common case we need is microgrid. So what you call is microgrid means it's an off-grid system. It's totally independent. So currently our customer, they have diesel engine in their island, or they have some PV ally, or maybe just don't have. So what we do is we collect those energy to our BSS system and provide it to the load. And for this kind of situation, we can provide for the island or off-field mining or oil fields. There is a remote village. Let's move on. We will talk about this case later. And the commercial and the industrial BSS. So for this kind of project, everything is about save money and the financial balance. So what we will provide is on this image. So you can see this black line is indicates as the price of electricity. And in all over the world is the same. In the night or in the afternoon, the price is very low compared to the peak price. So for the battery, what we do is we collect the energy from the value price and discharge the energy from the peak price. So for this kind of situation, the battery can create a profit for the project. And if we calculate correctly or install correctly, the payback period can be very low, as 2 years, as 3 to 5 years. So that's what we expect for this kind of system. So some key features for that. The first one is on and off grid switch. So for our product, we can switch from the grid and the off grid and the batteries with no time. The signaling is dynamic extension. So the dynamic extension is you start from the small project and you can extend the batteries or extend the inverters based on your needs. Then the DC supply. So the people who knows the electricity, you know the battery, or the storage, the DC power. So the DC power can directly connect to the DC supply. So this is most convenient solutions if you have the EV cars. Then is the PV accessories. Then we can, everybody knows. Okay, then is our cabinet. So what's the difference between the home use battery and our cabinet? The first of all is safetyness, because you put a lot of battery together, that will dramatically increase the risk of fire and explosion. So that is the most important thing. Then is the maintenance. So if we provide the unit cabinet, the maintenance will be much more easy compared to the individual system. So let's move on. Oh, not finished yet. Let's talk about what we have in the cabinet. So in cabinet, first of all, we have the EMS system, so which is a battery management system. This controlling the status of the battery. Then is the PCS. PCS is an integrated system including the inverter and the transformer, battery, and the switch function. And the third part is EMS. So EMS is not just battery; it's the integrated system. If you have the diesel engine, if you have a windmill, like that. Then the last, the battery module unit. So the battery module unit is different with that home use. Because for this kind of system, you maybe need the liquid cooling or maybe the fire extinguisher. So for the safety, we will integrate all those functions together in our module. So this is the inside of our system. For our customer, we have two choices. The first one is integrated cabinet. So everything is in one cabinet. This is easy to maintain and easy to install. And secondly, we can split the function in the different cabinets like this. So for this kind of project, it's more extended function compared to the integrated. Something. So let's say the inside. So there is unit cabinet. Here is the battery. Here is the PCS. Here is the power switch, and the AC. Also some control system. And if we use a split cabinet, so here is the control system together. And this is there is a battery unit. This part is the AC for the battery. And here is the battery unit. Let's move on. So here is some basic structure for your understanding. So the blue part is the physical side. And this part is software. So the software, we have the power control system, and it takes control and information from the energy management system. And the PCs will control the battery to tell them when it's charging, when it's discharging, and how to charge, and what's the limits of the charge. And for the battery, it takes the command from the battery management system. So this is just a rough idea. Let's go to more details later. Okay, so this is our container. Why we use container? Because for some customer, he has his location very far from the city, and it's hard to maintain it, hard to install. So what we have is we put everything together in China, in our factory. So once you get the container, you can install and use. So it's more faster for your remotely project. So some key features for our cabinet. The first one is low noise. So the low noise is most important for the customer who are having the diesel motor, a diesel generator. So for our system, it will have only 65 EP in 1 meter distance. So it's very quiet. You can even put in the room with no problem. Then in the high efficiency. In the morning, Ivan is mentioned about the distance of the wiring. So the wiring will decrease the efficiency. So if we put everything together in our cabinet, the efficiency will maximize. Okay, here's some videos. So for this kind of the cabinet, the cooling is a most important part. So for air cooling, there has advantage and disadvantage. So for the advantage, this is the most cheap solution you have. So it's very easy and easy to maintain it. And if something happens with the fan, you can just replace it. And let's go to the liquid cooling. So for liquid cooling, it's more, let's say, complex. But the good side is there has more efficiency than the air cooling. And the most important thing in Malaysia is because Malaysia is near the sea. So everybody knows the sea from the wind from the sea is salty. They will rot the system. So if we use liquid cooling, the only part have contact with wind with this part. So all the batteries inside is totally isolated from the environment. So this is more stable for Malaysia's situation. So if I can choose, I will consulting as this one for our primarily suggested. And another one is fire extinguisher. So the fire extinguisher in this part is put the powders inside of each cabin. So the good way is powder didn't damage other related units. So if this part is in fire or there has sparklings, so the powder will only release in this part, and the rest part will keep it safe. Then is the second fire extinguisher. So in case of some part is totally damaged and the fire is already being happened, and the explosion is ready to go. So we have this kind of system to support that situation. We will put the water to drop everything in this cabinet. Okay, so this was some details for the product, but later I suggest we go to the official website and check the details. We just skip this. Okay, so we just finished our product. Here is our project process. So if you have this kind of project, you need the full team support. What we provide is the project manager for your project. Then is tech leader. So the tech leader do is they will consulting everything for your project to give you the full plan for everything. Then is the electric engineer, software engineer, and transit support. But because some project is big, so you need the transit support to do the schedules for your project. Then is our after sales engineer. And that part is the project work breakdown, but I don't want to go through it because every project is different. Okay. So here is our established time plan. And this time plan is for 1 megawatt project. And the most important part is here. So after we produce, we need 2 weeks to do the integration. So this is we do the check, we do the connection, and we do the settings for our system. So that will help to the installations. Okay, finally we go to the case here. So the case here we have 4 parts. Is for all kind of the situation. The first one is the off-grid powering plant. So this is here. So for the island, most of our customers, they have diesel engine. So what we want is we do the system which can cooperate with the diesel generator. For example, normally you need the generator running every day, 25 hours. But with our system, this can only run like 5 or 4 hours. They will extend the life of the diesel generator. There is somebody who wants to use full cycle for their plan, so we can provide the PV panel as well. And in this system, we have 3 main parts for our customer. So the first one is the cloud EMS system. So what we say cloud? Cloud means you can use your phone or your laptop to check the status for that. This is the function 1. And function 2 is what if you have some trouble in your system. Our engineer in China, we can help you to find your problem by using the cloud. And we can do the remotely suggest or the remotely maintenance for your system. That's what we provide. Then is the PCS system. So the PCS is power control system, which including the inverter. So you don't need no more inverters and a transformer and various connecting control systems. And then is our battery. Okay. So combine that, we can provide the power to the load and the EV car. Let's move on. So here is the comparison between the diesel engine and PV plus BESS system. So in our case, we imagine our customer has this kind of building, and this building, before they meet me, they use the diesel generator. And what they use the lighting, 5 kilowatts fridge, 0.5 kilowatts pump, and the AC. So totally, they will use 400 kilowatt hours in one day. So if they purchase the diesel generator as 13 kilowatts, and based on that, we are providing two situations for them. So why is two? Because we have the basic one. The basic one means it works. It can replace the generator when the weather is good, when the sun is good. But everybody knows it's not really happens. So we have our comprehensive, complete project. So this project can hold like 2 days of energy support. So the basic one, we have 96 kilowatts for the PV and 150 kilowatt hours for the battery. So some key cost drives for this project. So everybody knows the diesel engine, it takes oil to run it, fuel to run it. Then it has to be maintained to change the oil, to change the filter. But for us, we don't need it. It's just keep everything clean. It's easy to maintain it. Then the lifespan for the diesel is 8 to 10 years for one. But for the PV for our currently project, we are normally designing 25 years lifespan for our customer, not just 5. The warranty is 5, but we design them 25 years. Okay, so let's do the financial. Let's start from here. So this is the price for the total system, the basic one. So the total system will include the PV panel, battery, and some other stuff, and the inverters. The total is 216K in total. And for annual operation and maintenance cost, we calculation as 2% or 3% for the average price. So we get the price for the system. Let's go to see the price of the difference. So here is the initial fund. You can see that our system will be much more expensive than the diesel engine. Diesel engine is more cheaper. But the things going to difference after 5 years use. Because 5 years use, the average diesel cost is already much more than the initial cost. But for us, they are 0. So we calculate the 1 kilowatt price LCOE for each one. The diesel engine is 1 MYR for 1 kilowatt hour, but for us, it's just 0.4. And then if you calculate to 25 years, it will be much more dramatically different. So let's go to the conclusion. For our payback period, we are calculating as 3.6 years. How to get this conclusion? We use our initial investment and compare to the annual savings to the diesel engine. So this is the number. And we're asking the past customer, the average payback period is almost like that, between 3 or 4 years. Okay, so here is the list for overall system. But if you buy from us, we will provide solar panel and the PCs, which is off and on-grid inverters. Then is the diesel battery combiner, solar panel combiner. These 2 combiners is just a box. There's nothing special. And then is the PV mounting kits, cable, connector, cloud, transfer, tariff tax, installation, commission. So this is what we can provide. And then if you have your current diesel generator, we can arrange our local support team to help you to do the commission between the diesel engine and our system. Okay. This is the second case we're going to share. And for this one, the main part of that is customer, he has the fish. And the pain point for fish ponds, if you meet the blackout, if you have no power in the grid, all the fish will die. So the result is very bad. What do they need? They want the backup system. So the backup system is our battery. And my customer, they have a second backup project, which is diesel generator. So in this project, our power provider have generator, grid, and also the battery. So we can combine everything together and provide it to our customers. I just skipped the words. Let's focus on the results. So for this kind of project, what we can provide is we can provide the automatic transfer switch between in the millisecond, so it can instantly switch from the grid to our system. So keep every machine works and without switch. Secondly, is our inverter can support the off-grid mode. So if the power is cut off, it will switch to the battery. Then the BESS begins power critical loads. So this critical load is a strategy you can set in the EMS system. So you can set in our cloud. For example, if the power was cut down like 2 days or 3 days, you can set after 1 day, we keep the 13% or 15% of our energy in battery, but we only release in the low voltage, so it can be last more longer than the normal situation. Okay. Third one is on-grid peak shaving and cost-saving case. So this case normally used for the factory, shopping mall, or like hospital. In this case, they use the power from the grid, but they think the electricity bill is too much, too expensive. They want to save some money. So what we can provide is use our system to save the money from the peak price. Here. So this is a message to how to save. So you can see this blue line is the price for the grid, and this orange line is the electricity price when we have the grid and our BESS system. And the red line is once you install the PV system, which will lower the price in total. So this is the idea for the commercial project. So let's go to the project. So in here, the yellow part is the electric price in the Malaysia. So you can see it's floating, it's not stable. So our plan for our potential customer is we provide the 200 kilowatt for the PV system. And for the battery, we are providing 2 megawatts. Because the more capacity you have, you can save more money. The capacity is a profit space for your project. So let's see the saving. So here is bill paid to the grid. So if you use the current system, only the grid, so it's the 57K for a month. And then if we use our system, we can take the profit from the grid to the 24K each month. So this is just peak shaving and same cost. Then we can have more revenue from the PV system, the solar panels. So the income for the PV panel is simple. What you install, what you earn. More you install, more you want to earn. So overall, in this system, it can be saved as 39K for each month. But we must see the overall price. So for this kind of system, our initial total investment will be much more, which is 1,800,000 for the system. So it looks too much, right? Looks too much. but the monthly saving will go to the around 40K, so it's a lot. So based on that, we can calculate our simple payback period, approximately 4 years. So the 4 years, I think it's good. I think it's good for this kind of project. And because it's just 4 years payback, after 4 years, like 5 years, 6 years, will be more saving. So after that, it makes more money for you. Then let's go to the lifetime for this project. Everybody wants to use more time because more time is more saving. So the PV panel, our design is 20 years warranty. And the inverter is 10 years warranty. For the residential, for that product, it's just 7 years. But the way we give our customer 10 years because this is our own product and our own maintenance. We can guarantee it has more stability for the system. Then the PC is 5 years. Battery, 5 years. So did everyone know once what happened if the warranty is expired? Do you know what happened if the warranty expired? Fine. Let's move on. Let's look this one. So once the warranty was expired, we provide the extended warranty service. And the extended warranty service normally take 1% or 2% as the total price as the warranty. And during the warranty, anything happen, we will repair and replace that. So here is the annual failure probability by years. So you can see from the beginning is 0 year, and this line is what we have, the numbers of failure happening from the 0.35 to the 0.75. So means if you use this system until 25 years later, the maximum failure times will be 0.75. So it's, to be honest, compared to the residential system, this is very, very low for our customer. And you can see how it decreases. And why it have two lines? This line is you have the regular maintenance, and for the yellow lines means you have take serious maintenance. Means if you have something problem with battery or something, you replace it instead of fix it. So it can reduce the failure time for your project. Okay, so move on. This is the fourth case. So we just let's do the quick summary for our previous work. First one is island. Island is totally off-grid. So everything you earn is from the PV panel. So that's the revenue for that. The second one is fish pool. So the fish pool is we can provide the blackout and some profit. And the third case is on-grid case. On-grid case. So for on-grid case, we take revenue from the grid. So this is the fourth case. So the first case is virtual power plant. Virtual power plant is our main business in Europe, which is I in charge, so I know a lot about this. And in China, they also have same issue. So what will happen for that? Let's say this part. This is the old grid. The old grid means the government uses the fire power generator to create a stable power to the grid and to your home. But what happens now? The government, they use the regular power station and wind and the solar. And everybody from the solar company, you know the solar power is not stable. It happens in the afternoon, but in the night it's cut off. So because of this character, the grid will take serious pressure from there. For in the night, the grid has no power. It will damage, and the power is not stable. And because not just that, for the home, for our company, we also provide the power from the solar panel and the wind and even the battery. So the grid become more stable, more unstable. So what we do for this kind of project, which is we sell the flexibility from the battery to the grid and make profit from that. That is more profit than you can earn from the PV and the peak shaving. Why? Why that? Because in the Germany, let me take an example. In Germany, their current grid system is only designed for this. So if you add more, they have to spend more money to build more line, more grid. But for that government, they don't want to pay, or they don't have money to pay. So what we do is we provide the job as a grid. So we are the grid. We can take the money from the grid. So here is what we can get from the FCA. FCA means the frequency containment reserve. This is what we earn. You can see it's lots of money for that. And why I present this kind of case? This kind of case is what we can provide to our customer. We can provide the container, we can provide the control system, and we can provide the operation team for you. So let's move on. This is some price for the European market. You can see the highest price happening in the Poland. So 1 megawatt power costs 117 euro for that. And in some case, here in Sweden, the price is minus 0.96. Who knows what happens if you sell the power to those kind of markets? So if you sell your electricity to there, you have to pay the government. Instead of they pay you, you have to pay them. So for this market, they just need more battery because they don't want to lose money for it. So what's happened in Malaysia? So in Malaysia, as I know, the national grid TNB is control everything. And if you want to sell your electricity to them, it will take average 12 months to complete the process. So the reason I put here is for our project in Europe, our payback time is 2 or 3 years. So if the average process time will take 1 year, so whole system will be not quite profitable to us. So for now, I think the Malaysia market is not enough to do this kind of business. But the reason I present is I think maybe in the future, Malaysia will do the same. Because I think Malaysia company is just a government, just like European governments, they might meet the same situation with no enough grid infrastructure. So if that happens, this market will be open. Okay, so this is the final Q&A. So the first question is, can diesel generator connect to the BESS? Oh, sure, it can be connected. And it can be your backup system, or our battery can do the backup system for the diesel generator. And the secondly is how to do the commissioning between the generator and the BESS. So we have our own customer, and that customer meets the situation. Is they have the 5 generator in the location, and they purchase the 100 kilowatt hours battery, and they find the generator is still running, is not stopped, because they assume the generator will be stopped sometime, but it's keep running. The happen is that guy or that customer, they didn't do the commissioning. So what is commissioning? Commissioning is you have to adjust your voltage and the frequency to the battery. And most importantly, the generator needs to take command from our system. Our system needs to tell the generator when it's stopped, when it's open, or when it's running, when it's closed. So this is must be done. And for the old generator, they don't have this function. So they can add the small equipment called the smart gene or something else that can reserve the command from our system. So combine everything, we finish the commissioning. So the system will be complete. Otherwise, it's just a waste of money. Then the third question is how to extend BS system in future. This is all depends on your demand, but you have to keep everything in balance. For example, you have 20 kilowatt inverter, and you have the 14 kilowatt for battery. That's its balance. It's 0.5%, or no, 0.5 compared to the inverter and battery. But if you have too many batteries in there, it's useless because the charging time will be much, much higher. It's the same idea as the PV. For example, you have large PV but small inverter. So the battery will be only in charge or discharge and never stop. So it's waste the capacity of the battery. Then the final question is, how can we start our project and what's the minimal set for the PV system? So this also depends on your needs, but one thing I have to say is bigger is cheaper. So if you plan to build the large scale, you better go through there. Don't add more after you build. Because once you adding more equipment, you are not just adding the batteries, you're adding everything. And in that time, the installation fee and the maintenance fee will sky high. Okay, so this is my presentation for the beginning, and the next part will be our proposal for our customer. So, does anyone have problem with this? About the financial project, product list? Okay. Let's move on. So this is our project proposal. So the reason I want to show this because the last presentation, the last event, I didn't show this proposal. And after event, somebody told me, I want to see your proposal. And I find out everybody was interested about this. So this is what we can provide. So before this, I want to say, if someone has a project, you can find us. We can provide the proposal for you, also including the price, how to install, and everything. We can do it for free. Okay. So here is some situation for that. So this case happened in Kenya, in Africa, and this is a government project. The government project requires us the 200 megawatt PV panel and 100 megawatt energy storage. And what they use? This used for the VPP project. So you can say even the African have a VPP. So everywhere, if they don't have the good infrastructure, the basic infrastructure, they do have the VPP needs in there. Okay, the demands, background, let's go through it. And some basic design. Okay, 200 megawatts for the PV, 60 units for the integrated status, and the overall PC output, PV Ally, energy storage, capacity, power. Oh, and one thing about power and capacity. So you can see the power total capacity is 100 megawatt hours, and power is 50 megawatt hours, which means the battery can charge 0 to finish in 2 hours. And for the VPP project, this is a very important indicator for that. They want to quick charge and quick release. Okay, this signal stage. Here is some structure, but this is the same with the previous project, so let's get it. So solution. Here is we can provide for our customer. We will select different types of PV panel based on your needs. So there only have 2 features important. The one is monophase or biphase. Biphase and monophase, you can only take the electricity, the sun, from one side. But biophase is including the back. And everybody knows if they have bio side, it's more efficiency than the mono side. But the mono side is more cheaper. So this is depends on the project. And then is our system. There we can sum up that. So it's the same. And then is how to install it. So for this kind of project, we want to grow some plant under the solar panel. We want to use this land. So we suggest them to use more higher structure, like 2 or 5 meters, so you can work under the PV panel. Then is our technical design. So here is what you need to pay attention. This is the income, financial income for your system. So we can calculate for you which year you can get, and then totally 25 years. This is the lifespan for our common commercial project. And it's decreasing like 0.5% around each year. And that's all. I think I have to zoom it out. Here. So for this kind of the project, every energy loss will spend money. So what we can provide is we calculate each loss of each type of the situation. Like this is the last of the total radiation on the incident surface. And here is the PV loss due to the irradiance, and the PV energy loss due to temperature. So this is what we can do. Okay, this is some still need to zoom in. Okay. This is what we choose for our customer. So normally we choose the bigger one because bigger one is easy to transit. But why we choose small? Because in the Africa, the temperature is too high. So if you use the big one, the heat in here is too much. It's hard to install the AC in there. So what we choose is we choose the small one. They have this space for the battery, this space for the PCA system. And the maintenance people can live here. This is also the office for them. And here is how to connect the system. This is what the function we have in the cloud. And for cloud, everybody is the same. Cloud is open platform for each one. And this is some key feature like lighting protection, cable laying, how to lay the cable, and mounting method, monitoring, and the building structure design. And this is also some details. Oh, here is quotation. So quotation, what happened for quotation? If you have this kind of the project, we will give you the initial quotation, including everything. But once you choose to use us, you need to pay us the visit fee. So we will send our engineers to your field. If your field is big, we will send our engineers to the field and we will provide the report for you. So the report will include the real cost for the project. So that time you will understand how much cost you have. So after we give the real quotation, we can process the project. And this price, this just a guess for this project. And we will provide also the internal team cost outsourced service cost, but now it's pending because we didn't see the location yet. This project is still in the bidding time, And this is the revenue, and the revenues from the first year, 5 years, 10 years to 20 years. And then you can see the revenue is getting higher. Let's see, but it should be higher, should be much. One 5 years past is more higher the revenue. Okay, see, this is another case here in China. But what we put here is we have the capability to take this kind of the project. And this is the total cost for this project. We will list everything in there. So you can see a lot for this kind of project. From the boat to the socket, to the people, what they use, and the labor cost, everything together. And also the certifications or something others, blah, blah, blah. Okay, some plan, risk mitigation, and the conclusion. Okay, that's it. That is our proposal for this kind of project. So this is everything. Do you have more questions to me, or project, or anything else?
Yeah, I was wondering if you guys have ever done any research on maybe sinking the whole battery system in the river, like just like fully submerged battery system.
Submerge? Yes, we do that.
You guys do that?
Yeah, we have this, but it's not very common because it's more expensive.
Yeah, in terms of like maintenance and stuff, yeah.
Yeah, you have to change the oil. That is most bigger expense for that. So normally we didn't recommend that system, but we can do that. We can do that. It's most efficiency cooling system we have. Yeah.
Yeah.
Are you a tier 1 rated?
Sorry?
Are you a BNEP tier 1 rated?
I don't understand.
Is your batteries solution BNEP tier 1 rated? BNEP Bloomberg Net.
It's kind of
standard. It's standard for BSS.
Yes.
So you are one of the under which brand?
For this kind of project, we are own brand. We build our own systems.
But it's under LVFU. Under LVFU.
Yeah, LVFU. We build our PCs and the cloud.
At BNEF1 tier 1.
T1.
我用的那个是
彭博士的，那不是最高级不是BSS 有吗？我知道，但是你们是不是切换的 qualification？
他那个人是就是他低的这个。
认证我知道，切换 BNEF tier 1， 意味是什么呢？意味是说你的 solution 我可以带过去银行，对不对？
我们现在目前我们这个产品已经会在热浪阿里。
对，可以带。
对。
我搜索，只按那个名字 LVFU。
LVFU 是我们的。
你可以把它说simulation. Can you do somewhat like a simulation? How you would approach to a peak shaving cost savings program? 再给你这个吧。这个是一个落魄法。
哦，
这个是一个中大的小的做法。
啊，
那我知道你凭你经验的话呢，要切在哪里？要放你的 VSS 给 capacity。
就看你的预算。
对，就要看你的预算，你想需多少，
你想哪个时间段学多久？
我从这个 graph 来看的话，我就不能学这个，因为它的显示在最差的，我最能够是呢，就是我写的在这，它的 gradient 最高的话就是最理想，对吧？
大家的反馈，我们还是1000项，也高了。
因为现在目前来说 ，nowadays, are you aware that the maximum demand for tariffs has increased from 40 ringgit to 90 ringgit? Yeah. So this is going to impact a lot on the industrial. So that's why I want to ask you, do you have a solution or guide step to teach us as a potential customer how to do the calculation and how to get more business onto the doorstep?
I think I can do this because I didn't have to do this in my life. I just do in other
Yeah.
我们之前就是 steel factory，我们是做过跟他们做过相关方案，这个要根据你工厂的一个具体的情况来。
我就是给那个 local profile 跟那个
到这个我们就可以，是的，主要是这个 LVFU 有这个。
对。
So I just translate. So this is a load profile. So
this is a plastic.
This is fine. So if your guys use our system, it will be much more lower. So you can get the income from the picture from that. And what this gentleman mentioned is about, we have the combo, we have the plan or project for this. And I answer is currently we only have the example for our customer. So Sherry has this kind of plan. So if you have a question, you can ask for Sherry. And for me, because I'm from the Europe, our plan is not suitable for this situation. So you can ask Sherry.
What project have you done in Poland for the DPP?
DPP. We are currently running 120 megawatts project. Yes.
Do you do financing in Poland?
Financing, you need to rent.
If you did finance the whole project.
Currently, we have active. Currently,
I have a project in Poland, and it is 50 megawatt. I have the whole.
If you can let us to join the income, we think we can do that.
Okay.
And you can find it.
Okay.
Nice. So do you have more questions? Or
I think I share with you in the group here some information I have is that if you're looking at LSS and on-grid interfacing, one of the first and foremost prerequisites is that the systems that you put in must be DNEF Tier 1 registered. If you're not, then you're out of the game. So that's for sure. Surrender the Naga Energy Commission of Malaysia has released it as part of the criteria. So if you're not in that category, the only area that you can look into is the CNI area. CNI is commercial industrial. So commercial industrial, they're not so stringent, but the safety standards of ST or Energy Commission of Malaysia must also be complied with. 对，你们申请在 ST 那边的话呢，必须要有一个认知，你们的产品呢是符合safety 条件。
我们是有 IC 的认证。
不知道，但是你要做多匹配，你们要申请上去，然后呢，
这个一般来说，不是我们去申请，是当地的安装商他们去申请。
对，只要两，我端马来西亚安装商只是进口，我们是不还的，等的。
我们有本地安装商，他们现在我们非他不像我们现在就是说安装商在帮这个欧尔去申请 DST 申请。
一定必须要申请。
对，他安装商会帮我们去申请。